Hi everybody and welcome. Today we're going to be talking about the Pythagorean theorem. So after watching this video, you will be able to identify situations where the Pythagorean theorem applies and additionally do the calculations that allow you to solve for missing sides and right triangles. So this is honestly one of the most useful skills we'll see this year because this is something that can be used in a variety of places, a variety of labs, and for solving for a variety of unknown quantities. So the first thing that we want to just kind of review are some of the basics of right triangles specifically. So if we take a look at what we see here, the ground's in a wall, assuming that the wall is perfectly level and the ground is flat, we're going to see a right angle, and that's a 90-degree angle. And what that 90-degree angle tells us is a whole bunch of properties about this triangle, and one of those properties is that the Pythagorean theorem applies. So let's talk about the Pythagorean theorem. So this is a relationship between the sides of a right triangle. So in this example, we're going to see above that wall works because, again, there's a nice right angle there. So that is okay. But if we see something where it's like an obtuse triangle, more or less something that just doesn't perfectly fit, we're going to see this is not an example of something that we're allowed to use the Pythagorean theorem on. So the Pythagorean theorem is a squared plus b squared equals c squared. And there are some specifics that we need to make sure we have clearly established about a, b, and c. So yesterday, we talked about the hypotenuse being the longest side of a triangle. It is also across from our 90-degree angle. In addition to this, though, we have two legs. So we have a leg here, and we also have a leg here. So anything that is not a hypotenuse is a leg, and the legs actually are kind of interchangeable in some ways. So it doesn't really matter which one is which. As long as one of them is A and one of them is B, they can go back and forth. But the only thing that does matter is your longest side length is C. So the hypotenuse here must be C, and the C can only be the hypotenuse, so that goes both ways. So anytime that you see a right triangle, what you are going to want to make sure you do immediately is make sure that you have your 90-degree angle, and directly across from it, label that side as your hypotenuse. Label that side as C. For A and B, it really doesn't matter. Again, either one can go in either place, and you're totally fine. So here, if we have right angles, and let's assume, and I'll tell you that they should have been marked. These are right angles here. And directly across from it, we'll label it as C. Directly across from it, we're going to label this as C. A and B, again, pick your poison, whichever one is fine. Choose whichever option is easiest for you. And then that's how we get this set up. So two different ways, two different situations. You can have a leg missing, or you can have the hypotenuse missing, but it won't make a difference because either way we're doing a squared plus b squared equals c squared. So wherever you see your A, in this case, A is right here. Wherever you see your B, and wherever you see your C, you're just going to match, plugging those into your formula. So 17 squared plus b squared, and then 19 squared. So punching these into our calculator, 17 to the second power is where we're going to start. We don't know what b squared is, we're just going to leave it as b squared, and then 19 to the second power is where we go next. From here, we just continue to solve, so we're going to subtract 289 from both sides. So we're left with b squared equals 361 minus 289, and again, just calculator math here, get 72. I'll take the square root of both of these. So if you're using a TI-30, hit second, top left corner, and then x squared, which is right next to the left of the number 7 digit. That should give you a square root symbol. When you do that, you can punch in 72. You'll get approximately 8.5. So we're just rounding here. So there we go. So b is equal to 8.5. So we solve for our missing side length. We know that b is 8.5. So a similar situation for our next one here. So we'll zoom in on this. So again, a squared plus b squared equals c squared. Highlighting is always good for color coding, so we can see what and where everything comes from. So a in this case, see that's 5. B in this case is 13. And then c, we don't know. So once again, 5 squared in the calculator, 13 squared in the calculator, and then again, nothing there for c squared. So put the two terms we know together. They're on the same side, so we don't have to move anything over, which makes our life a little bit easier. And then last step, root both sides. So again, second x squared to get the root function on a TI-30. And 194 gets us 13.9 for C. So that's how we have it set up here. And again, we are in good shape. Always good to double check that your hypotenuse is your longest side. So 13.9, that is the longest side of this triangle. So good to see that we have all the obvious things there. So basic mechanics for doing the Pythagorean theorem: identify the sides and then plug into the formula. And now we're going to see the good news of this, which is how useful it is in the real world. We can see some applications. So two joggers run 8 miles north. So they start here, north is up, so they go up by 8 miles. And then they run 5 miles west. Well, west is to the left, it's towards California. So there we go, 5 miles there. And they want to know what's the shortest distance to get home. So all that this is doing is just forming a triangle. I'm going to rewrite the 8 because that was our first length. So just forming a triangle here. And when we form this triangle, we can see that we have a nice right angle occurring here. So across from that right angle, we're going to label our point C. And we can go ahead and solve from here. So I'm going to pause the video for a moment and just allow you to solve. Try this on your own and see what you get as an answer for C. All right, so a squared, b squared, and c squared. So we'll identify a as one of the sides, b as another side. And the only important thing here, a and b can be mismatched, it's okay, as long as c is the side across from the 90-degree angle that we do not know. So 5 squared plus 8 squared from our blue and red highlights for a and b. And then we just continue to work through here. So we end up with 89 equals c squared, and then we can take the root of both. And again, you can probably hear the calculator buttons for me. A lot of calculator math here. So c is equal to 9.4. So that right there gets us an answer of 9.4 for what we're looking for C. So as always, thanks for watching. Let us know if you have any questions. I would say a big calculator math day and a really, really important day to make sure we're labeling A, B, and C and hypotenuse and making sure everything is in the right place. So questions, let us know, but you're ready for the practice problems. Thanks for watching.